Hey everybody, welcome to BSN, which is Byte Size Networking. Today we're going to take a look at command prompt, specifically 4 tools that are an absolute must-know for any IT technician or engineer. It really will strengthen your ability to troubleshoot problems related to networking specifically. The commands that we're going to go through today, firstly will be ping, P-I-N-G. Then we're going to look at Ipconfig, and then we'll look at Nslookup, and then we're going to look at traceroute. All right, so here we are. Just a quick note, I will be doing a video on the basics of command prompt, how to navigate, create directories, move around through directories, just an entry-level video um, that you guys can have a look at if you're not at all familiar with the command prompt. This is more geared at entry-level junior technicians, and I'd like to introduce a couple of tools. So the first command I'd like us to take a look at is ipconfig. So when we type ipconfig into the command window here, you'll see it gives you a list of all the active network adapters on your machine, both virtual as well as physical, as well as wireless network adapters. So I'm currently connected to my wireless network at home, and you can see wireless LAN adapter Wi-Fi. It'll tell us what the IP address of my machine is on the network. It'll tell us what the subnet mask of my home network is, and it'll also tell us what the default gateway is on my network. So just to elaborate a little bit more on what these things are, this IP address here is the IP address that has been assigned to my machine. This is the subnet mask of the network, of my home network. This will also give you an indication of how many available IP addresses there are in this IP range. And then the default gateway would be the routing IP address. Anytime you're trying to access something that is outside of this network, like for example the internet or a resource on another subnet, that traffic will be directed to the router, and the router will then direct the traffic from there to ensure it gets to its location. All right, let's clear the screen. You can get more information from the ipconfig command, so let's have a look at how we get that done. We can type ipconfig and put a space /all. It's then going to output quite a lot more information related to our network adapter. So again, here we're looking at my Wi-Fi adapter because that's the one I'm currently using to connect to my home network. Now, in addition to what we looked at previously, you'll see there's a description which tells us more about the actual network adapter, the model and specifications. It also then gives us the physical address, also known as the MAC address. Every network adapter on a network, on any device that connects to a network, has a MAC address, a unique MAC address. This also tells us whether DHCP is enabled on this network adapter or not, meaning that when I connect to a network, this adapter is going to send a request across the network to request an IP address that it can use to connect to this network. And then auto configuration enabled, yes, that will speak to it getting the IP address, the subnet mask, the default gateway, as well as the DNS servers, all from the DHCP server on the network. Okay, then as mentioned previously, we get an IPv4 address. We saw that in the previous command, as well as the subnet mask, as well as the default gateway. Now, in this command where we put the /all, we can also see when the IP address was issued to our machine from the DHCP server on the network and when the lease will expire. So we will take a dive into DHCP in another video, how it works, how the lease times work, how you set up scopes and all of those things. But for the purpose of this, we won't get into that. This command also tells you where to find the DHCP server on the network. So we know that my home router's IP address is 192.168.8.1, which is our default gateway. So it's doing the routing, but also my DHCP server is running on my router. And then if you look at DNS servers, also DNS is running on my router. All right, the next tool we're going to have a look at is ping, P-I-N-G. So to note about the ping command, we're going to say type in the command P-I-N-G, and then we need to specify an IP address of of another machine, a computer, really anything. So we know that my router was 192.168.8.1. So let's send a ping request to that and see what output we get here. All right, so let's break this down quickly. We can see we ran the ping command and we specified my home router's IP address. So the output is as follows. We were pinging that IP address with 32 byte packets of data. We got a reply and another reply and another reply and another reply. So we got 4 replies. And down here under ping statistics, we see 4 packets were sent and 4 packets were received in return and 0 packets were lost. So this tells me that my connection to my network or to my router specifically is 100%. I'm not losing any data packets. And if I look at the time taken, the milliseconds, it is nice and low. I am connected to the wireless network. If I was plugged in with a network cable, on the local network, you don't expect to see more than 1 millisecond here. Sometimes on the wireless adapter or the wireless network, your signal maybe isn't as strong as it should be, or there's some interference of some kind. But as long as those numbers are relatively low, you're okay. Another interesting way that you can use the ping command is to ping the loopback address. Now, what that means, a loopback address is you're asking the ping command to ping the local network adapter on this machine. So sometimes if you're having issues with drivers or the network card, or you're not sure if the network card on the machine itself is faulty, a good test to do would be to ping the IPv4 loopback address in IT is 127.0.0.1. That range has been reserved for loopback address. So if you ping that, I'm now getting responses from the network card in this machine. So you can see there the time is less than 1 millisecond, less than 1 millisecond, because it didn't actually have to arrive at a destination and be returned. We're just pinging the network adapter in this machine. We can also ping um, internet IP addresses. So for example, I know one of the public DNS servers that Google has is 8.8.8.8. So let's do a ping request to that. Ping, and I want to ping 8.8.8.8, and I'm getting a response. So just to give you guys a bit of an analogy that under what circumstances you would find something like this useful. If I'm connected to the network, um, I run my Ipconfig command and I see, okay, great, I've got an IP address, that's working. But when I open Google Chrome, I still can't get to the internet. But I've got an IP address and I've got a subnet mask and I've got a default gateway. What you can then do is try and ping 8.8.8.8, and I'm getting a reply, which means I can get to my router, I can get through my router to Google's DNS server, and I'm getting a response from that server. So immediately I know that physically there's no problem with my connection. You can also ping host names. So, perhaps you don't know the IP address of Google. You can actually do a ping to google.co.za. Now, when you do a ping to a host name like this, you're actually learning 2 things. Number one, you're obviously connected to the network and connected to the internet. That's the first thing. And secondly, you know that your DNS is working because you pinged www.google.co.za. Your machine then sent a request to the DNS server that it knows, which is my router at home, which we saw in the previous Ipconfig section. And my router then said, okay, the IP address for google.co.za is this. Then ping executed the command. So if I was connected to the network and the internet, but I still couldn't open a web page, but I come to command prompt and I can ping 172.217.170.3, I get a response when I ping that IP address, but when I ping the host name, I then, if it fails here, I then know there's a problem with DNS on my network. So ping can be very useful in number one, checking that your network adapter on your PC itself is working. Number two, checking that your computer can communicate with the default gateway on your network. Number three, checking if your computer can communicate beyond your router with IP addresses out in the www, World Wide Web. And then number four, you can also identify if the DNS server that your machine is trying to use is actually functioning correctly and resolving IP addresses. So you can see just by how you think about and how you apply this tool, it can be quite useful to identify a couple of basic things or narrow down where a problem could be on your network. So the next command we're going to have a look at is going to be Nslookup. Stands for name server lookup. So really what we're doing is we want to query whichever DNS server our machine has been told to use and say, hey, DNS server, I need the IP address for dns.google. Let's see if we get a hit on that. There we go. So we've got a response saying, okay, Google has these DNS servers available, 8.8.8.8, 8.8.4.4, and it gives us two IPv6 addresses as well for those same servers. Now what we've just done there is a forward lookup. We've contacted the name server and we've said, please give us the IP address for Google DNS. And it did respond with the IP addresses for Google DNS. You can then also do what you call a reverse lookup. Same command, nslookup, but instead of specifying the host name, we only have an IP address. So we want to say, hey, please tell us what the host name for this IP address is. It'll then respond and say, this is Google DNS or dns.google. So this is a very simple way to see if DNS is working on your system. When I say that, I mean your computer is successfully getting correct responses from the DNS server it is trying to use. So Nslookup, quite useful in that way. All right, the next one we're going to have a look at, and the last one, is the traceroute command. Now you'll see I already have it running here, traceroute, and I did a traceroute to amazon.com. It does take quite a while because each of the hops will get recorded here, but the command in its standard form like this is busy resolving IP addresses to host names for every one of the hops. So it tells you what the host name is and what the IP address is, what the server name is, and what, or the FQDN, the fully qualified domain name of the server is, as well as the IP address. So this takes quite a bit of time to get all these responses, but you can see here how it's showing us. Okay, so to get to amazon.com, we know that we need to get out of my network. So first we're hitting my home router, then we're hitting my internet service provider, and from there we're getting directed to amazon.com. Okay, let's cancel this and clear the screen. So here I'm going to use traceroute switch D. Now, what the switch D means after the traceroute command means that I'm not asking it to resolve all the IP addresses along the way and specify what the host names are here. If you ran just traceroute google.com, you would have noticed in the previous output we got that we had the fully qualified domain name of each of the hops as well as the IP address. Here we're not asking it to do that. All we're wanting is for it to show us where the connection breaks or times out and what the IP address of those hops are. We can then take further actions ourselves to do Nslookups on those IP addresses if we really want to know what the host names are. But to unnecessarily slow down the traceroute command doesn't really make sense. So I think this switch D is quite a useful little trick just to speed up the command at times. All right, guys, thank you very much for your time. Thanks for watching. There'll be many more videos coming on various topics. You know, there's a lot we can delve into. So let me know if you guys found this video useful at all. If there's anything you think I should have touched on that I didn't, please feel free to leave it in the comments below. I will check out the comments, respond, and if there's anything specific you want me to jump into on the next video, I'm happy to do that. Keep well, guys. Until the next time.